Let's talk about nested functions in Python. Python's functions can be defined pretty much anywhere. You can even define a function inside another function. When we call this greetMe function, it defines a greet function and then it calls that function. Note that the inner function is allowed to use the name variable from the outer function. Instead of calling our inner function, let's try returning it. To use this function, we can assign the return value of greetMe to a variable. This variable points to a function. To use this function, we can call it by putting parentheses after a reference to it. This works because functions are objects in Python, and like any other object, we can point a variable to them or pass them around. Note that the name variable in our outer function sticks around even after that function has returned. Each time we call the greetMe function, we dynamically define a new greet function. Each greet function we make this way will have a separate name variable available to it, which is independent from the other greet functions that we might have made the same way. The name variable isn't a local variable, but it's also not a global variable. The name variable lives within the enclosing scope of the inner greet functions. When a function is defined within a function, and the inner function accesses variables that are defined in the outer function, Python uses a closure to keep track of those variables that are defined just outside the inner function in its enclosing scope. You mostly don't need to think about a function's enclosing scope or think about the closure that it makes. Closures are just something that happens behind the scenes, and they pretty much just make nested functions work the way we would expect them to. For example, here's another function that defines an inner function and returns it. Each time we call the makeOuter function, it will return a new add function that has a different x variable available to it. So this add4 function always adds 4 to a given number, while the add5 function always adds 5. The word closure is most important for language implementers. For regular Python users, we usually just think of the variables that we're able to access rather than the fact that we've made a closure. Those variables are accessible within our innermost function, even though they're neither local variables in our function nor global variables. This is neat, but why would we ever define a function within a function? Well, here's one use case. This partial function can sort of preload a future function call with specific arguments. Now hex to int points to a function which will call int with the keyword argument base set to 16, as well as any additional given arguments. This is sometimes called partially evaluating a function. This partial function is a decent example of a function defined within another function, except this Python standard library already has an implementation of this function in the functools module, and it's called partial, just as our function is, and it even works a little bit better. This ability to define functions within functions isn't seen very often, except it's very commonly seen when using a specific Python feature. Decorators. A decorator is a function that accepts a function and returns a new function that replaces the original function. Decorators almost always involve nested functions. In Python, it's possible to dynamically define a function within a function, and we can even return the inner function so that it can be called later. Nested functions will automatically keep track of the variables in their enclosing scope. That is, the variables that are defined in the outer function. Decorators are by far the most common use for nested functions in Python.